stikstof. Elkeen van hulle het 5 valensie elektrone. How many valence electrons do we have in total? 10, né? So as ons nou gaan en ons teken hulle so teen mekaar, stem julle saam, daar's nou baie meer elektrone as wat ons het. Don't draw that, Lydia. It's wrong.
I'm drawing it so that I say it's wrong, so that I don't do it.
I'm drawing it so that I don't draw it. Okay, want hierso is 8, 9, 10, 11, 12, 13, 14. You agree? 14. Okay. Nou, hierdie is so half 'n mathematical trick wat jy kan doen. Okay, stem julle saam, daar is net 10 elektrone, maar ons het nou 14 elektrone. Okay, so hoeveel het ons te veel? 4. So in other words, those 4 electrons we will have to shift in between the bonds. Okay, so met ander woorde, ons moet nog 4 elektrone daarin sit. So stem julle saam, daar's nou 6 elektrone in totaal. Okay, and then you just fill them. So hy lyk so. Met ander woorde, as ons gaan kyk na daai stikstof, is hy happy? Hy het sy 8 elektrone. And if you go looking at that one, hy het sy 8 elektrone. Okay, toe het ons laas jaar vir onsself so 'n bietjie van 'n wiskundige formule gaan uitdink. Soort van, I don't know. Ons het gedink ons is baie oulik. Okay. If you take the amount of electrons you would have had if you just added them like that, okay, and you subtract the amount of electrons that you actually have available. Ek moet dit nou net nie opborsie. Okay, and you add 2. Then that divided by 2 always gives you the amount of bonds that will form in between the 2 atoms. Hierdie is nie 'n chemie reël nie, maar dit werk. Jy kan net sê daar is 6 elektrone tussen hulle ook. Maar omdat ek hier by 3 uitgekom het, beteken dit is 'n trippelbinding. Okay, let me try and put that into sort of something that looks like a formula. Do you all know where I got the 14? It's if you just go and fill them in like this.
So
It will usually be 14.
What if it's not?
It's not going to be 14 when we move on to the rest of them. No. I don't want to say it will always be 14 because maybe I'm lying, but it will always be 14. Okay. Okay, so you get that from just filling them like that, and then you subtract the available electrons. The 2 that we add is because there is 2 in between them, but you don't have to know that. It will always be 2. Okay, and then if you divide that by 2, it'll give you the amount of bonds that form. But like Bertha said, if you just keep it at 6, then you know there must be 6 electrons. So you can do that as well. Don't write down this formula somewhere. It's not going to give you any marks. I mean, you can write it in your book, but I mean like on a paper, no one's going to mark this because this isn't in a rule book somewhere. Dit is net iets wat ons gesien het werk. En ons was baie chaff met onsself. Yes. Sê weer? Hoe kan jy doen? Yes, presies dit, né? Maar ons gaan nou aanbeweeg na wanneer daar, so sê nou maar byvoorbeeld CO2. Né? So dan is dit nie meer die atomiese elemente nie, dan gaan ons na molekules toe en dan werk die reël nog steeds. Maar jy's heeltemal reg, hierdie is lekker maklik om te sien, want hierso is 2 enkels en hierso is 3 enkels, so obviously gaan hulle met mekaar verbind. Goed. Okay. Weer, hierdie is nie 'n chemie wet nie. It just works. Sommer. Okay. Now, so those are D. That is when you are working with diatomic elements, basically. Okay? So diatomic elements, O2, N2, wat ook al. Okay. Goed. Nou gaan ons aangaan na wanneer dit nie enkel bindings is nie, so double or triple bonds, but you're not working with diatomic elements anymore. Something like, for instance, water, which is always the example we go to. So we're going to go to H2O. Hy's eintlik nie 'n goeie voorbeeld nie. But we're going to do it anyway. So, wat belangrik is jy moet weet watter atoom kom in die middel van jou molekule. And there they have those steps put out on page 17. So to choose your central atom. Now this is normally something that is quite easy to spot. Okay? So if we're working with H2O, which one will be in the middle? The hydrogens or the oxygen? Obviously the oxygen. Okay? But sometimes it's not that easy to spot. For instance, I think your books are wrong. Lees gou vir my in die Afrikaanse boek by daai stappe wat hulle sê, wat sê hulle by stap 1? Kies die sentrale atoom, wat sê dit dan? Maar suurstof het 'n hoër elektronegativiteit as waterstof. Sê hulle omtrent altyd. Okay, dankie. Goed. Okay, so with this one it's easy to spot. It's going to be oxygen. And we fill in 1, 2, 3, 4, 5, 6. And then with hydrogen, we have the 1. And with hydrogen, we have the 1. Why is this important to me? It is so important that when I ask you to draw the Lewis structure of hydrogen, you do not draw this. It is wrong. Because they are opposite one another. They have to be next to one another. And how do we know that? Because that is how you fill your orbitals. You start with 1, 2 in the s orbital. Nee? En dan begin jy op 'n punt. So ek begin hier aan my regterkant. 1, 2, 3. And then you go back to where you started for your next one. So if you fill your orbitals correctly, do you agree that it will always be 2 spots next to one another that is available? En guys, dit is regtig die struktuur van water. For reals, when you go and look at a water molecule, it doesn't have a water in the middle and 2 hydrogens at a 180-degree angle from one another. In fact, ek dink die hoek tussen hulle is iets soos 92, iets. Dit is in julle boeke ergens. Okay, but you don't need to know that. So, it doesn't look like this. It looks like this. Hulle lê langs mekaar. Hier is 'n groot spasie oop. Dit is belangrik dat julle julle orbitale reg moet vul. Okay, so